Next section we're going to talk about how do we go about multiplying matrix. We added and subtracted and did scalar multiplication in the first lesson. So now we're going to talk about how do we go about multiplying matrices. When we're multiplying matrices, we've got to keep this column and rows thing in our backs of our minds, because the first thing we have to be able to do, or the first thing we need to do when we're seeing if we can multiply, is we have to do exactly that. We have to see if we can multiply them. So the first step that we have to do when we're multiplying matrices is we have to check to make sure that we can actually do it. And there are rules for this. So the first thing we need to do is we need to be able to check to see if those matrices can in fact be multiplied together. So let's say that we have the matrix 5, 1. So we've got 2 rows by 1 column. This is a 2 by 1. And we're going to multiply that by the matrix 4, 1, negative 2. So we want to multiply these together. And this matrix is a 1 by 3 matrix. So when we're multiplying matrix together, we have to look at the columns and we have to look at the rows. And the first thing that has to happen in order for us to do this is, once you determine what their rows and their columns are, you want to kind of look at that middle term. And that right there, that piece right there needs to be the same. Okay, so we've got a 2 by 1 and a 1 by 3. The number of
Austin
columns.
High School, we are in a lockdown. Austin High School, we are in a lockdown.
See, we even do lockdowns when you guys aren't here practicing. So anyway, so we have to make sure the number of columns in the first one matches up with the number of rows in the first one. Okay, and that's going to lead us to figuring out what type of matrix it could be. Okay, but you always have to first check to make sure that the number of rows in the number of columns in your first one matches up with the number of rows in your first one, and that has to be your first check. So let's look at a second one. So let's look at the matrix 5, 1 again. But now let's take it with the matrix 6, 2, negative 4, and 9. So we've got 2 rows and 1 column, so that's a 2 by 1. We've got 2 rows and 2 columns in this one. Notice that these two don't match up. So since those two don't match up, we cannot multiply those two matrices together. Again, the rows, the columns with the first one needs to match up with the rows with the second one in order for us to do this. Okay, so this one, in fact, in this direction, cannot be done. And we'll talk about more about the why here in just a little bit. So after we've checked to figure out if we can make a matrix, the next thing we have to look at is we have to figure out, okay, how big is that matrix going to be? So step 2 is essentially to figure out how many rows and columns that your new one's going to have. So in other words, what's the dimensions of your new matrices? How many rows is it going to be? And how many columns is it going to be? Well, we go back to the first one and we look at the number of rows in the first one and the number of columns in the second one. And then that is going to create the dimensions of our new matrix. So we're going to end up with a 2 by 3 matrix. So we've got a 2 by 1 and a 1 by 3. The end result to this one is going to be a 2 by 3 matrix. So we're always going to kind of do that check to make sure it can be done. And then once we make sure it can be done, it scares you when they shake that thing and you know what's happening, whatever. Once we know it's done, then we have to figure out what its dimensions are going to be. So obviously the second one down there, we couldn't do it. So therefore, we don't have anything to make it out of. We're just simply done. Those two can't be multiplied together. So now that we've checked to see if it can be a matrix, and we figured out what the new dimensions are, how do we go about creating or multiplying two matrices together. So how to do it? So how do we go about doing this? This is actually probably number 3, but whatever. So let's just do in generic. Let's go with A, B, C, D. We're going to take A, B, C, D, and we're going to take that times E, F, G, and H. So we're going to multiply these two matrices together. So we first dimensions, we've got a 2 by 2 and a 2 by 2. We look at the middle numbers. They're the same, so that gets a check. It can be made. What is our result going to be? Our result is going to be a 2 by 2 matrix. So therefore, we know when we multiply these together, we are going to get a 2 by 2 matrix. Okay? So we're going to have something here, something here, something here, and something here. We've got a 2 by 2 matrix that's going to be created by multiplying these two together. Now, how do we determine what we're going to do, or how do we multiply these to get this? So I can't just take A times E. That's not going to be sufficient. That would be like, no. So what we do when we do these is we multiply rows by columns. Okay? And we're going to get the result. So really, in the first one, we're really concerned about the rows. So this was row 1, this was row 2, and that's what we were concerned about, that part of it here as well. In this part, in the second matrix, we're really concerned about the columns. So this is column 1, and this is column 2. So what's going to go in this first spot is going to be your row 1 and your column 1. Okay, row 1 and column 1. Well, if you notice, there's like 4 different elements. We've got A and B in row 1, and we've got E and G in column 1. Well, how do we put them together? You multiply. Okay, we multiply A times E. So our first one is going to be A times E. And then to that, because they're in the first spot, first 1 and 1, 1 and 1, to that, we're going to take B times G and multiply them together. And then we're going to add those two pieces to each other. So in our new one, the first row in our first column is going to be row 1, A times E, plus B times G. Rows by columns. It's always rows by columns. So how do we get what goes in this second element here? Well, we're still, if you think about it, we're still in row 1. This is row 2. This is column 1. This is column 2. So that right there is in row 1, column 2. So that means we're going to use the elements from row 1 and column 2. So A and F are in the same spot. So it's going to be AF plus B times H. Okay. Now we go down to the next one. What's down here? Well, I look at it and I'm going to go row 2, column 1. So row 2, column 1. That's C times E. That's C times E plus D times G. What's going to go in the last spot? Row 2, column 2. CF, C times F, plus D times H. That's how we go about multiplying them, and that's kind of the style that you're going to follow when you're multiplying these matrices together. It's always rows by columns. Multiply the elements and then add the other set of elements. Okay, so AE plus BG is how we go about doing this. So let's go back to that original matrix that we made. We had 1, 5. Okay, so we had 5, 1. And then our second matrix that we had was 4, 1, and negative 2.
Austin High School, we are all clear. Austin High School, we are all clear.
We're clear.
You may resume activities as normal.
Seems like I continued my activities as normal, except for I walked over to the door and locked it, which is probably good because people have been interrupting me all day today. Anyway, you're going to get to me in the light because I'm not going to walk over there. Okay, so we've done the check with this one. We've already said that this is a 2 by 1, and this is a 1 by 3. So we've got these two are the same, so that checks off. Our new matrices is going to be a 2 by 3. So I'm going to go ahead and I'm going to draw a 2 by 3. So it's got 2 rows and 3 columns. So it's going to look something like this. And now remember, it's rows times columns. So first row, first column. What's in the first row and the first column? 5 times 4. So that's what this is going to be. That's going to be 5 times 4. This piece right here is first row, second column. First row is 5, second column is 1. So this is going to be 5 times 1. I don't have anything to add it on to, so I just got to move on. The last one, first row, third column. 5 times negative 2. Now we're into the second row. Second row, first column is 1 times 4. Second row, second column, 1 times 1. Second row, third column, 1 times negative 2. So then our resulting 2 by 3 matrix here is 20, 4, 5, 1, negative 10, negative 2. That's the result of multiplying those two matrices together. Step 1, check to make sure you can do it. Step 2, figure out what your dimensions are going to be. Step 3, rows and columns. It's always rows and columns. And move yourself about however it is you need to do it. Let's go 1, 4, and 7 times 3, 6, 2, 4, 1, 8. So I'm going to take these two matrices and multiply them together. Okay, so first got to be check. So we've got a 3 by 1. We've got a 2 by 3. Those two things aren't the same. Can't multiply them together. You simply say that. We can't multiply them together. Next one. Let's go 1, 4, 2, 3, 1, 0, 2, 6, 3. Okay, so we've got a 3 by 3. So I want this one to work, so let's think about it. I want it to work so I could go like a 3 by 2. So let's do a 3 by 2. So let's go with, I need 3, we're gonna go 3 by 2. So 3 rows, so 0, 1, negative 2. I just need 2 columns. Let's go with 3, negative 1, 4. So I look at my rows here, they're good. That makes up. My resulting matrix is going to be a 3 by 2. Personally, I'm going to have 3 rows. Make it a little longer. I'm going to have 3 rows and 2 columns. I just kind of like to draw that just to kind of help me out. Rows by columns. So we've got 1 times 0. So we're going to go 1 times 0 plus 4 times 1. I'm just going across the row and down. Plus 2 times negative 2. Okay, I'm going to make this bigger. plus 2 times negative 2. Just waste your time. It's more fun that way. First row, second column. 1 times 3 plus 4 times negative 1, 2 plus 2 times 4. Okay, so I've got the first row done. Second row, so we go second row, first column. 3 times 0. So we went 3, 0. Now we go 1 times 1 plus 0 times negative 2. Second row, second column. 3 times 3 plus 1 times negative 1 and 0 times 4 plus 0 times 4. Now we go to the third and first. 2 times 0, 6 times 1, 3 times negative 2. Third row, second column. 2 times 3 plus 6 times negative 1, 3 times 4. Now, is it necessary that you write all of this out? No, but some of you maybe noticed when I was doing this kind of what's happened. If you notice, if I look here, here, and here, notice how all of those are the same, which they should be because they're the columns. It's just kind of my own personal little check to make sure it works. Okay. Now, I put my pen down, see if I can make this page a little bit bigger so I can write on it further. So now we just finish off the math. So we've got negative 1 plus 4. So negative 1 plus 4 minus 4. I'm going to leave that open. Go across, we've got 3 plus negative 4 plus 8. Oh, geez, that's 0. See, you got to be careful. That's 0. This is 0 plus 1 plus 0, 9 minus 1 plus 0, 0 plus 6 minus 6, 6 minus 6 plus 12. Shrink it again. Finish it off now. That gives us 0. That gives us 7. That's 1. That's 8. That's 0. And that's 12. And there it is. Now, does all that work make it confusing? 100%. And you got to be very careful. Obviously, 1 times 0 is 0, and I messed that up right away. But I caught it. Okay, so you have to be a little bit careful, and who knows? There's probably another error in there somewhere. But I don't know. I'm going to go with it. Looks right. If you find an error in there, let me know. But that's a basic concept of what we're doing and how we're going to go about doing these. Really, again, it becomes this row times this column thing that you got to kind of get used to. Element, element, plus element times element plus element times element, and so on and so forth when you're doing these. Would I write the first one down, the 1 times 0? Probably not. It helps. It's a nice little check to make sure that you're doing these correctly, but it can also lead to some confusion as well. So just be careful when you're doing these to make sure you're okay. So let's look at another one. So let's go 3, 0, -1, and 2. So I've got a 2 by 2. So now I want to do 2 rows. So let's do 0, 1, 4, 3, 6, and 8. So we've got a 2 by 2 times a 2 by 3. So it can work. Our end result is going to be a 2 by 3 matrix. So we've got 2 rows, 3 columns. Who knows if I have enough space to put it in there? Rows times columns. And I'm just going to go 3 times 0 is 0, plus 0 times 1 is 0. So my first element is going to be 0. Now I'm going to keep going across. So first row, second column. 3 times 4 is 12. 3 times 0 is 0. So 12 plus 0. First row, third column. 3 times 6 is 18. 0 times 8 is 0. So there I've got the top taken care of. Now I go to the second row, first column. -1 times 0 is 0. Plus 2 times 1 is 2. -1, now second row, second column. So -1 times 4 is -4. Plus 2 times 3 is 6. Last one, -1 times 6 is -6. Plus 2 times 8, 2 times 8 is 16. Now we can go ahead, we've got 0, 2, 12, 2, 18, and 10 is the resulting matrix. First matrix, -5, -3, -4, -5, lots of negatives, -1, and -5 again. Second matrix, going to multiply them together. It's -2, 2, -3, -5, 3, and -6. Okay. Why don't you go ahead and check to make sure it can be. You've got a 2 by 3 and a 3 by 2. So, yep, it can be done. So you have a 2 by 3 and a 3 by 2. So, yep, result's going to be a 2 by 2. So go ahead, see if you can get to the solution. Okay, there's your solution. And again, if you need to press pause right now, kind of see how I did it, go ahead and press pause right now. This isn't the easiest thing to do, this rows and columns thing. These can be a little bit challenging sometimes. Let's look at another one. Let's go with -3, 2, -4, 0. We're going to multiply that with the matrix -5, 6, -1, 2, -6, -1. Okay, go ahead, give it a shot. Check it first, make sure you can do it, figure out what the dimensions are, and then go ahead and finish it off. Okay, so you should have got the matrix 27, 7, 16, 24, and 24. You multiply those two together. One more. And again, if you're good right now and you know what you're going on, just you're done. I mean, you don't have to sit and watch, 700 of these going on. If you know what you're doing, go ahead and just move on with these today. And that's all you're going to work on is kind of this matrix multiplication today. And you're just going to use just one step of matrix multiplication. So if you're ready to go and you think you're good to go, go ahead and kind of start your work for today. If you would like to do one more, I'm going to do one more to make sure that we're good to go. So we're going to go -3, 3, 4, 3, 6, 0 times 3, -6, 0, -1. Go ahead. Okay, so there's your solution for that last one. So matrix multiplication. Today, you're just going to work on an assignment that's just specifically deals with just matrix multiplication in single form. We're going to spend another day on this. This is kind of one of those 2-day things. Tomorrow we're going to add, more to it. We're going to multiply, then add. We'll put several operations together tomorrow when we do the matrix multiplication. We also have to introduce what we call the identity matrix. We'll introduce that tomorrow as well. So we're not quite done with section 10-2. Got a little bit to go with it. A little bit of a long video today, but a lot of examples in there because this stuff is, can get quite confusing until you start to get down the patterns. So again, we're going to work on this another day. Those of you that are on the Monday, Tuesday group, this one's probably being shown on Monday. And we'll do the second day on Tuesday. We'll spend time on Thursday and Friday making sure that we work together and to make sure that we know and understand how to do this stuff. The homework's there, everybody. Have a great day. We will see you when we see you.